Thank you so much for joining this lesson. Mathematics paper 2, just as I had promised. This lesson. That is what we are going to handle tonight. So make sure you're following keenly. Remember to share this live lesson with your friends so that we may reach a lot of people. Just click the share button. Ensure you are sharing with friends. Just ensure that you are reaching out to as many friends as possible. So I'm going to post the mathematics paper 2, which we are going to revise tonight, right away on the screen. Make sure you have your calculators, and make sure that you're writing materials for you to catch up with everything. Mathematics paper 2 is basically Form 3 and 4 work, and that is what we are going to revise tonight. So this is a mock papers which have been done by one of the serious schools around, and I hope you are going to benefit this night. Determine the percentage error. Section 1. Determine the percentage error when 2 and 2 out of 13 is written as a decimal and truncated to 4 significant figures. In this question, a student is supposed to understand several mathematical concepts. It might look simple with only 3 marks, but a student must understand what a percentage error is. Again, a student has to understand how to convert decimal into a fraction, but for this case, a fraction to a decimal. A student is also supposed to know what truncation is. Then a student is also supposed to understand the language of significant. So all those concepts are supposed to be understood so that a student will be in a position to answer this question. So let's start by first of all changing the number which has been provided into a decimal. When we are changing 2 and 2 out of 13 into a decimal, we should know that 2 is already a whole number, so we'll be having 2 points. Then we take 2 divided by 13. This is 0.1538. So 1, 5, 3, 8, 5. This is to 5 decimal places. But now the examiner is talking about truncated to 4 significant figures. So when we talk about truncation, we just count the first significant figures as they have been communicated. That is the 4 significant figures. Then we fail to consider the 5th significant figure, whether it is above 5 or below 5. So what we're going to count is the first significant figure, the second, the third, and the fourth. So the 4th significant figure is 3. Even though after 3 there is a 5, we are just going to truncate up to that point. So we're going to work with 2.153. That is the meaning of truncation now. 3 is not increased, even if the number after that is greater than 5. That is the meaning of truncation to 4 significant figures. Now, we have truncated to 4 significant figures, also changed the number to a decimal. So the bigger part is now done. We go to part error. First of all, what is an error? An error is the difference between the accurate value and a truncated value, even a rounded off value things. Therefore, we're going to first of all obtain the error. Let's first of all get the error, which is going to be the difference between 2 and 2 out of 13 and the truncated value. This is going to give us This is going to give us a 8 point. This is a 8.4615 times 10 power negative 4. The next thing will be now working out the percentage error. Now we are having the error. For us to get percentage error, we need the error itself. We divide by the actual value, then we multiply by 100 to make it percentage. 0.4615, the actual value, that is 2, and 2 out of 13. Now this one by 100. This is the time now you should make very good use of your calculators. Therefore, I'm going to multiply by 100, then I divide by 2, and 2 out of 13. So now from my calculator, I'm getting 0.3929%. This is to 4 significant figures. It's good to estimate your values to 4 significant figures. Accuracy has not been specified by the examiner. Let's go to number following. Continue sharing with friends. So benefit. Number 2, given that the sine of 15 equals to root 6 minus root 2 divided by 4, 1 divided by the cosine of 75. So we are going to handle surds, and at the same time, we're going to handle trigonometry. There is a concept in trigonometry 1 which is being evaluated here, so that now through the concept, you may be able to solve surds. It's good to know the relationship between 15 and 75, and that is the sine of 15 is the same as the cosine of 75 degrees. This is because are complementary. We know that for two complementary angles, the sine of one is usually equal to the cosine of the other. You can confirm that from the math tables, you can confirm that from the calculators, but it should be understood that the sine of an angle equals to the cosine of its complementary angle. Now that the two are complementary, then it's simply solving the reciprocal of what has been provided here, because this one is just the same as this. Therefore, we are solving the reciprocal of root 6 minus root 2 divided by 4. So now we're going to solve a surd, which is starting with 4 divided by 6 minus root 2. That is the surd which is solving. To solve a surd, we must multiply both denominator and numerator with the conjugate of the denominator, because we are rationalizing the denominator. So this will be multiplied by the root of 6 plus the root of 2. Then we do the same at the numerator, plus the root of 2. So on the numerator, I should have 4 root 2. That's after opening the brackets. Then I divide by, this one is being divided by, when you look at the denominator, whereby I've multiplied a surd and it, multiplying a surd and conjugate gives us something that we call a simplified difference of two squares. So with a difference of two squares, which has been simplified, we can expand it. And we know that for us to expand a difference of two squares, we just need the square of root 6 minus the square of root 2. And this is going to give us root 6 squared becomes 6, root 2 squared becomes becomes 2. Therefore, I need 6 minus 2. We continue simplifying. So we're going to have, remember, root 6 divided by 4. And now that in the numerator there is 4, and also in the denominator there is a 4, then I can factorize to remain with root 6. This is positive, sorry. From the numerator, we are having a positive. Sorry for that. Yeah, it's a positive. Then the root of 2. This one is divided by 4. And this means because 4 can simplify now, remain with the root of 6 plus the root of 2. So that is how we handle such a SAD. Let's continue working out the questions. Remember, it's good to share the broadcast with your friends. Number 3, make P the subject of the formula. Then we are given A divided by B squared minus C equals to C, and simplify your answer. So let's now work on this question. What we are supposed to understand is that because we are making P the subject of the formula, we can remain with the part with P at this side. Then this is going to be equal to C divided by, we divide it through by B minus C. B minus C. Then now we continue again to remain with P. We shall have C divided by B minus C. Then we subtract A out of B squared. Again, now we are going to simplify the right hand side because the examiner is saying, and simplify your answer. So it's not a, we leave it at that. Allow me to say now that P equals 2. We take the LCM, whereby we'll have B squared into B minus C. Then now this LCM can be divided by the first denominator, remaining with squared. So we shall have C, then B squared, minus A into, we divide again the LCM by the second denominator, which is a B squared, and we shall remain with B minus C. So this is the simplified form of such a formula. So that is the of P. Let's continue with number 4, the expression dx squared plus 16 is a perfect square where d is a constant. Find the value of d. Remember, on the screen, I have attached my number because there are people who consult. There are people who even request for these papers. We can share them as a document. Feel free to consult. Feel free to request for the revision materials. Let's continue with number 4. The expression provided here is a perfect square. It's good for students to remember that the terms in a perfect square are usually having a certain relationship, and that is when we take the value of B divided by 2, value of A multiplied by C. And according to what we are having here, B is negative 56. So we need to take negative 56. We divide by 2. Then when this one is squared now, it should give us the value which is unknown, that's our D, multiplied by C, which is 16. So let's proceed. We will take now negative 56 over 2, which is a 28 squared. This gives us 784. So 780, we have to divide 16. And this will give us D as exactly 49. So D equals to 49. In other words, if the examiner had told us to rewrite the expression above now with the value of D known, us 49 x squared, sorry, not d, x squared minus 56 x plus 16. This is now the perfect square. This is now the perfect square. Yes. We can proceed to number 5. Sometimes we are having geometry questions, and it might not be very effective for us to construct on the screen, but all in all, I'm going to give a proper guidance so that you people may know what to do. The figure below shows a circle and a point P outside the circle. Using a ruler, we can see the circle and a point Q, yeah, outside the circle. Using a ruler and a pair of compasses, locate the center of the circle, hence construct a tangent to the circle from Q. So let us look at how we can identify the center. Remember, there are some simple properties of chords and tangents related to circles. And one of them is whenever a chord is bisected perpendicularly, that bisector passes through the center of the circle. But now that using one chord, we might not exactly identify the center, then we are going to use two chords. Then their point of intersection is going to give us, the center of the circle. Therefore, roughly, because I've said I don't have geometrical instruments which can be used well on a screen, we're just going to estimate. Assuming this is a chord AB, we are saying the perpendicular bisector of AB will pass through the center. So let me draw a perpendicular bisector. That's a bisector. Perpendicular bisector of that chord passes through the center. But now that this chord is just alone, we cannot use it to identify the center. So let me come up with another chord, and we also bisect it. That's another chord, for instance, CD. If this chord is bisected perpendicularly, then this, or the bisector for such a chord, will pass through the center. So we have now identified center O. So this is the center O. We have center O. Now with our center, okay, it's good to know that if the first bisector of a chord is prolonged, of course a diameter, and now it itself. So we can still use one chord, which when bisected, the bisector passes through the center. Then now that we can be able to measure now the diameter through that bisector which is passing through the center, we can easily divide that by 2 and identify the center of the circle. So that is the center of the circle. In the process of constructing the tangent of this circle through point P, we first of all join the center to the external, join the center to point Q, that is, sorry. Then after joining center O to Q, we bisect. Again, we bisect. So we're going to bisect perpendicularly, of course, so that we may identify the center of OQ. We have to identify the center of OQ. So we identify the center of OQ somewhere here. So this is the center. We can call it center X. Now with center X, we are distance OX to make OX to make an arc on this circle. We use radius OX. To make an arc. Therefore, we shall make an arc at this point and also make an arc at this point using radius OX. Remember, I'm not having proper instruments. I'm just trying to estimate. So now when we join now, that point where the arc has been made to Q, we will have come up with a tangent to the circle through such a point. So that is how we do such a construction. So let me now come up with the tangent. Exactly. That is now the tangent. One tangent is enough. So when you follow keenly through my procedure, a student will be in a position to construct a tangent to a circle from an external point. We proceed to number 6. The question says, solve the equation given the logarithm of x plus 3 minus the log of 160x. This is equal to -2. Allow me solve this one by first of all doing away with the negatives in the equation. By, if we rewrite the equation starting with the logarithm of x plus 3, then now we bring 2 to this side. This is equal to 160x can be taken to the other side, and we shall have it becoming positive now. The log of 160x. Then now we proceed. I can choose base 10 in this equation. Even when there is a constant 2, log to base 10 is also introduced. Therefore, I'm going to have the log to base 10 of x plus 3 plus. So I write 2, the log of 10 to base 10, because we know that the log of a certain number to the same base is usually 160x. This is owing to the fact that in case we take the log of a number, let me write this law of logarithms using a different color. The log to base a is the log of 10 to base 10, the value of 2. But now I'm going to apply another law of logs, which says when we have n, the log of a certain number, this can be solved by taking the log a certain number, then the multiplier here becomes power to given to base 10 of x plus 3 plus, I write this one as to base 10 of 10 squared. This is equal to the log to base 10 60x. We can apply further laws of logarithms, like this law of logarithms, which says that, let me write the law again using a different ink, of a certain number, let's say to base a, plus the log of another number c to the same base. This can be solved by taking the log to base a, b, and c multiplied. At this point now, I can say we need to pick the log to base 10 of x plus 3 multiplied squared, which is 100. So this is 100. So we multiplied by x plus 3. This is equal to the log to base 10 x. Then now we can drop logarithms and we quit the right hand side and the left hand side. In this case, I shall have 100x plus 300 equals to 160x. So that when I group like terms together, I shall remain with 300 equals to 60x, because 160 minus 100 will give us 6. Therefore, the value of x when we divide by 60, we are supposed to get 5 exactly. So that is the value of x according to this equation. Let's go to number 7. You can see number 7 is a question on binomial expansions and expand 1 minus a third x raised to power 6 in ascending powers of x up to the fourth term, leaving the coefficients as fractions in their simplest form. So for us to expand any binomial expression, we are supposed to, first of all, list the binomial coefficients of the given power. And in this case, we are given power 6. Therefore, I'm going to write the coefficients of power 6 for the first 4 terms. So I will start with 1, 6, 15, and 20. 1, 6, 15, 20. So those are the first 4 terms. The first 4 terms coefficients. Now, when I will start expanding this, I should start with the first term, which is 1 raised to the total power, which is power 6. Then negative a third x should be raised to power 0. In the next term now, I will start with 1 raised to power 5. So the powers of 1 will be decreasing, while the powers of negative a third x are going to ascend. Negative a third x, but now raised to power 1. Then we shall have 1, now power 4, the negative a third x, now squared. And finally, in the fourth term, we shall have 1 power 3 and negative 1 out of 3x, also power 3. So now that is the first substitution. Let me now expand. With the first term, 1 power 6 remains 1 and negative x power 0 remains 1. Anything power 0 is 1. Therefore, we have 1 times 1 times 1, and this is going to give us exactly 1. Then we have 6 multiplied by 1 power 5, which is 1, and negative a third x power 1 remains the way it is. Anything remains the way it is. Therefore, now we have 6 times 1 times negative a third, which means 6 by a third is going to be 2, and there is a negative. The next term, we start with 15, 1 power 4, which makes it 1. Then we have negative a third. In the brackets, we shall have then x squared. That is what is being by 15. So 15 multiplied by 1 over 9. That's 15 over 9 now. 15 over 9 is a fraction in the simplest form, 1 and 2 thirds. So I will be having 1 and 2 thirds squared. And finally, I'll have minus. This is a 20. 1 power 3 is 1. Then negative a third becomes negative 1 out of 27. So I'll be having 20 out of 27, and x is now raised. So that is the expanded form with fractions in their simplest form. And again, we are supposed to know that the expansion was to go up to the fourth term. So we are done with the expansion. The next thing is to use the expansion. Use your expansion in A above to estimate the value of 9 out of 10 raised to power 6. 9 out of 10 raised to power 6. Therefore, we should take the original expression, 1 minus a third, x, because it has been expressed to power 6, let me just write power 6. This is equal to 9 out of 10, also power 6. Now that the powers are the same, we can equate now the bases and say 1 minus a third x equals to 9 out of 10. We can have 1 out of 3 to this side being positive, then 1 minus 9 over 10, which is 1 over 10 to this side, so out of 10. So to remain with x, we can multiply through by 3. X equals to 3 over 10, which is 0.3. Now with the value of x, we can replace it in the expansion up there, such that we have 1 minus 2 instead of x, 0.3, plus 1 and 2 over 3 instead of x, 0.3 squared, then minus 20 out of 27, 0.3 power 3. This is equal to, let me expand, 1 minus 2 into 0.3. Then I add 1 and a third multiplied by 0. Then I subtract 20, 27 that is, into 0.3 to give us exactly 0.53. 0.53. So that is what the expansion is giving us. Number 8, given that vector OA equals to 3i plus 4j minus 7k, and vector OB equals to 9i minus 5j minus k, and that R divides AB externally in the ratio 5:2, determine the coordinates of R. This is a proportional division of a line, and for this case, external line. Allow me to sketch these points. They are, of course, collinear. Now we are having the first point A. According to the coordinates here, I'm going to pick 3, 4, -7. I'm writing them as column vectors. Then we have another point B, which is 9, -1. Those are again the values. And finally, there is a point R, whereby the coordinates of R are not known. I let them to be X, Y, Z. Allow me give the ratios now. We are told that R divides AB externally in the ratio 5:2. So from point A to where R is, we have 5 units. Then back 2 units to where B is. So we have from A to B 5 units. Then from A to R 5 units, and from R to B 2 units. So we're going to write units. It means there are only, therefore we have a ratio of 3:2. Actually, if we take point B now to be dividing AR internally, it will do so at a ratio of 3:2. Simpler terms, let me say that when the word externally has been mentioned, we are given the ratio without negatives. That is 5:2. But in case we had not seen the word externally, and the examiner intends to evaluate the same concept, then he or she would have said that R divides AB in the ratio 5:2. In the ratio 5:2 means ratio 5 is to negative 2. Now, allow me state something about the ratio theorem, which is used to provide or to calculate unknown coordinates when given some vectors. We should know that in case this ratio is m, then this ratio is n. Then we know that the coordinates of B are given by, when we take ratio m and we divide by total proportions, m plus n. Then because we have picked m, we multiply with vector r, we add n, divide by total ratios, total proportions. Because we have picked n, the opposite vector, which is vector a. So this is to mean we can express the same and say 9, negative 5, negative 1 equals to, out of the total proportions, which are 5, and we multiply by the unknown vector xyz. Add ratio 2 out of the total proportions 5. We multiply this by coordinates of a, 3. Then we are able now for the unknown coordinates. Remember to subscribe and to share the link with friends. Okay. So now we can say 9, working with the x components. 9 equals to 3 out of 5x plus 2 over 5 by 3 will give us a. So now we can remain with 3 out of 5x equals to 9 minus 6 over 5, which is 7 over 5. Then now to remain with the x, we have 5 over 3. And this will be exactly 13. So the coordinates of x are 13. The next, we will take negative 5. Negative. Again, we take 3 out of 5y. Then we add 2 over 5 by 4 becomes 8 out of 5. So we can remain over 5y equals to negative 5. Then we subtract 8 over 4. That is a negative 5 minus 8 over 5. Then we add these by 5 over 3. Okay, we are getting negative 6 and 3 over 5. So to remain with y, now we have to multiply it by 5 over 3. By 5 out of is going to be negative 11. We're also going to talk about y, the coordinates of z, that is. So negative 1 equals to 3 out of 5 z. Then we add 2 over 5 by negative 7 becomes negative out of 5. And so we can remain with 3 out of 5 z. This is equal to, when we take negative 1 and we add 14 over 5, this gives us 1 and 4 over 5. Which means for us to get z, we need to multiply by 5 over 3. So by 5 out of 3. This is exactly by 5 out of 3. This is exactly 3. So now the coordinates of r can be stated. Then 3. of R. Thank you so much for remaining around. We are almost finishing. Number 9. Triangle ABC prime with vertices 1, 1, 8, 1. Then C, which is a 10, 7, is the image of the triangle ABC under the transformation matrix 2, 3, 5, 4. Find the area of the triangle ABC. The first thing we are going to get, let's work out the area of the first triangle, which is the image triangle provided. If I'm to sketch this triangle, let me just sketch it first. We sketch this one. So I'm having coordinates at point A, 1, 1, then point B, 8, 1, then point C, 10, 7. Therefore, if I take AB to be the length, following the x coordinates, I'll be having 7 units at this point. And again, from B to where C is, if I consider the y coordinates, now I'll be having from y equals to 1 to y equals to 7. That is going to be 6 units. So the perpendicular height for this triangle will be 6 units. So the area of the triangle, that is a prime actually, is going to be, when I take half multiplied by 7 by 6 units, and this will give us exactly 21 square units. 21 square units. The other thing which we are supposed to calculate is now the determinant for the matrix of transformation. Let's get the determinant for the matrix of transformation of elements in the leading diagonal. And in the leading diagonal, I can see 2, 4. Then minus the product of the by 3. So this is good. But now we usually say area scale factor equals to the absolute value of the determinant of the matrix of transformation. This means area scale factor. So when we take area of the image triangle, which is 21, divided by the unknown area of triangle, we are supposed to get area scale factor, which is 7. And so we will say that the area is going to 21 out of 7, and this will give us exactly 3 square units. So that is of the triangle ABC. Triangle ABC. So that is the area. We can proceed to number 10, a question on probability. Remember, we are being encouraged to continue sharing this link with our friends wherever they are. Let them get to benefit from shifting grades. I can see people asking how they can get these exams. And I want to assure you that this paper is available for free through WhatsApp on the number that you can see on the screen. So you can see a number attached here. kindly reach out to me after this broadcast. I'll be able to share with everyone. Somebody's requesting that I the most handle that. Part 10, we are told that Tom calls Mary once each evening before he goes to bed. He calls Mary's mobile phone with probability of 0.7 or 9. The probability that he answers our mobile phone is 0.8, and the probability that she answers her landline is Y. Given that Mary answers 75% of Tom's calls, find the value of Y, hence determine the probability that if Tom's calls is not answered, then it is made to Mary's landline. So we're going to come up with a tree diagram first of all, and from the tree diagram we shall be able to what we are being told. So we have a gentleman here called Tom who makes calls to a lady called Mary. This can happen through the mobile phone or through the landline. So mobile phone, the landline. Calling through the mobile, which means calling through 0.3. Then after that, now Mary may answer or not. So the probability of Mary answering, she may answer or answer. Also the landline, she may answer or not answer. We are told that the probability that she answers our mobile phone is 0.8. So if answering the mobile phone is 0.8, then it means not answering the mobile phone is exactly 0.2. I must mention at this point that answering the mobile phone call and not answering the mobile phone call are what we call mutually exclusive events. Their probability must add up to 1. So if one probability is provided, then the other should be concluded automatically. On the other side, we are told that and the probability that she answers our landline is Y. So answering landline is Y, which means not answering landline should be 1 minus Y, because again, answering the landline and not answering the landline are mutually exclusive events again. So they are supposed to give us 1. There are more information which is provided, and the information is that given that Mary answers 75% of Tom's calls, find the value of Y. Let us first of all find the value of Y. Given that Mary answers 75% of the calls, so the probability that she will answer a call is 75, and that is probability mobile phone answered or probability answered is 74%, sorry. So 74 over 100. Remember, probability expressed as a fraction. Probability can be expressed as a percentage, as a fraction. 7 by 0.8, or which means plus when we are dealing with a probability, 0.3 by Y. This should give us 74. And so we can now get, let's first of all remain with 0.3 Y being equal to 70, which is 0.74. We subtract 0.7 by 0.8 multiplied, and this will give us 0.18, which means we can remain with y by dividing through by 0.3, and this will exactly give us 0.6. Now that the value of y is known, we can now fill a few gaps and say this is a 0.6.4 now. Yes. It is that if Tom's call is not, then it's made to Mary's landline. So probability that the call is made through the landline and not answered. So we should talk about probability, landline, and not answered. So we'll have 0.3 now multiplied by 0.4. And this is going to be 1, 2. 0. So that is the probability that was required. That's a very technical question. Yeah, people are still requesting for these papers. Remember to WhatsApp me your requests. I'm going to consider them. Thank you so much. Okay, number 11. The wave 2y equals to A, the cosine of bx minus 20 as an amplitude of 2.5 and a period of 1080 degrees. Find the values of A and B. Then part B, state the phase angle of the wave. All right. In the first case, we should know that generally we can be given a cosine wave or a sine wave, and they are in a general statement. They are always y equals to, let's say, a value A multiplied by cosine or sine, then B multiplied by x minus 20 minus, okay, I'm general here. So let's say a certain angle data. Then from such a general wave equation, we should know that amplitude is usually the value of A. Then what we are calling period is usually 360 divided by the value of B. And finally, phase angle, the phase angle is usually given by the absolute value of theta, the absolute value of theta. So this is to mean that we need to first of all divide this by 2 so that the equation is in the format here, the general format. So y equals to A out of 2. Then now we shall have the cosine of bx minus 20. So from this, we can say that to multiply through by 2. So A equals to 5. The value is 5 in this equation. The next is to find the value of B. We are saying that a period, which is already provided, will be the same as 360 divided. So to get B, yeah. So to get the value of, we need to take 1080 over 360. 80 over 360. Not over 360, sorry, 360 over 1080 actually. Sorry, we want to remain with, so 360 over 1080. This is a 1 over 3. 1 out of 3. Then finally, we are stating, angle of the wave. So to state the phase wave, then we are supposed to know that the angle is just the absolute value of the angle stated there, which is exactly exactly 20 degrees. Exactly 20 degrees. So thank you so much for with this lesson. You can request for the paper according to the number provided there. Remember to share with your friends. See you later. Thank you.